we're going to focus on the water terms as well as addressing some of the parts of the water cycle. Just as a reminder that water comes in 3 different phases or 3 different states: solid, liquid, and gas. Water is also a compound. It consists of 2 different elements, oxygen and hydrogen, and this is a polar molecule or bipolar. The oxygen has a negative end while the hydrogen has a positive end. And as we demonstrated in class, that as water is going to be attracted to other water molecules, it's going to have a strong hold on each other, especially on the end or on the surface outside of a water droplet. And this is called surface tension. This attraction or the strong pull or hanging on of these water particles, these water molecules, to each other, especially on the surface layer. Just a reminder, when 2 water molecules are attached to each other or attracted to each other, this is cohesion. But when 2 different things, such as water and a plant, water and your skin, that stickiness of water sticking to you, that is called adhesion. Now, we're going to talk about the water cycle briefly, and then we'll talk about some terms that are review, and then we'll go back to the water cycle. But the first thing that we have to know are some terms that tie in with the water cycle, and the first one is melting. Now, this does not play a huge part here, but it is part of the water cycle in which when solid water turns from solid to liquid, such as if we have ice or snow that starts melting, this can actually lead to erosion. Now, this usually happens in mountains where we might have mudslides. Now, freezing usually ties in more with the condensation precipitation part. When we have water in the clouds, basically when it starts to freeze, we're going to have snow, sleet, or hail as a precipitation, as a form of precipitation. Now, vaporization is basically the same thing as evaporation, but evaporation is at the surface. Now, vaporization is turning from liquid to gas. This is when the sun starts warming up the water and the very top surface layer starts moving faster and faster, and then that water becomes a gas, and that is evaporation. Now, condensation, a great example of that would be the formation of clouds. This is when the gas water rises up in the upper atmosphere and then loses heat and energy. It gets colder, and then it starts turning back to liquid. So it's going from gas to liquid now. And these water droplets start sitting on little condensation nuclei, such as dust or pollen. And these droplets float in the sky, and it forms a cloud. Now, a cloud is water, little droplets of water. A cloud is not gas, but it's actually droplets of water floating around. Now, when these little droplets of water touch each other, they start getting bigger and bigger. This is called coalescence. I'll say that term again, coalescence. This is when the water droplets hit each other and they get bigger and bigger. Now, when they start getting too big, too heavy, the droplets fall, and that's going to be called precipitation. So precipitation is when the water falls from the sky, from the clouds, and technically the clouds are just the water droplets in the sky. When it gets too heavy, they fall, and 4 examples of precipitation are rain, snow, sleet, and hail. Now, transpiration might be a new term for most people. Transpiration is the process in which water comes out of the leaf. Some people describe it as a type of plant sweat. But something you need to know is that just like how we breathe out of our mouth and nose, we breathe in and out, plants have these little microscopic lips. These little tiny microscopic lips are called guard cells, and they open and close, and they're all over the plant, mainly on the top and bottom of the leaf, There's actually more on the bottom of the leaf. But as they breathe, CO2, carbon dioxide, is going to go into these little lips, into the guard cells, and then oxygen is going to leave the guard cells. So oxygen is a waste product of the plant. That's what we breathe in. So it's going to go in and out of these little lips, these little guard cells. Now the space, when these little lips open, the space of the guard cell is called the stomata or stoma. Now, as you can see, the equation of photosynthesis looks a lot larger or maybe different from what you're used to. In elementary school, we have water plus carbon dioxide equals sugar and oxygen. And this happens in the chloroplast. But that's not a balanced equation when we're looking at the molecules. You will need to know that there are 12 water molecules for every 6 carbon dioxide molecules. And then at the chloroplast, with sunlight, with energy, it rips them apart, rips these molecules apart, rips apart the water and carbon dioxide, and then puts them back together. It reassembles them into sugar, oxygen, and more water. And that's the key. That's what most people leave off, is this extra 6 units of water. And when the guard cells open, water leaves the stomata, water leaves the guard cells, and it collects on the edges of the leaf or on the top of the leaf. Now, I don't know if you ever bumped into a house plant and a little droplet of water came off. That's actually from transpiration. So water coming out of the guard cells of the leaf while it's breathing is called transpiration. Now, when that water comes out of the leaf and then evaporates, we're going to take this term transpiration and combine it with evaporation. So that's going to be called evapotranspiration. Now, here are 2 terms that we talked about first semester, infiltration and runoff. Now, infiltration is a general term that just means going into the ground or going into something, to infiltrate. Now, when water is specifically going into the ground through spaces, these pores, that is called percolation. Now, when the water fills up all these spaces, all these pores between the soil molecules, and there's no more room in the soil, the water has to move on. So that is called runoff. And remember, we said 2 examples of that would be flooding and a waterfall. Now, as the water moves into the ground and under the ground, that's going to be called groundwater. And we said the ground that holds the water is called an aquifer. This page specifically goes into a little more detail or explanation of both percolation and runoff. Here are 2 pictures of runoff, flooding and a waterfall. And then we talked about when a rain or a rainstorm starts to happen, as the little raindrops hit the ground, it makes these small individual grooves called rills. Now, as the grooves get larger, they are going to form gullies, and then these gullies will then form streams. Now, smaller streams, as you can see here, are called creeks or brooks. Now, a very large stream will be technically called a river. So streams form rivers. As we talk about streams and rivers, just a reminder, some of the terms that we talked about before. The first one is a solution. A solution contains a dissolved solute, like a solid, like a salt, a mineral, and it contains a solvent, which is like the liquid, the water. So when you mix the two, the solute and the solvent, that forms a solution. Mineral water is a solution. Gatorade is a solution. Salt water is a solution. Now the second term, a suspension. This is actually when we have clay, silt, and sand mixed in the water. It's not dissolved. It floats on top or throughout the stream or river. This is what makes the stream or river look muddy. And then the last term there, we have bed load. This is when the material is not suspended, but it's dragged at the bottom of the river. This is usually with sand, pebbles, and larger rocks. Now, a river usually is going to cut through the ground, through A V-shaped valley is going to cut through the land where you have on the left and right side of the river, you have the hills or mountains. Now the base level is going to be the lowest part of the river cutting into its bed. It's the lowest part of the river. That's the base level. And then we talked about the watershed. The watershed is where all the land that is holding the water, now the watershed is all the land that drains into the river. It's all the land that's actually having the water where the river and streams are interconnecting. And so a watershed is the area that's going to have streams and rivers drain into a larger river or drain into a lake. And as a river or stream leaves a mountain valley, it's going to carry a lot of sediment. It's going to have erosion and then deposition. Now the deposition usually happens in a fan-shaped pattern, and we're going to call this the alluvial fan. As we talked about waterfalls, at the bottom of the waterfall, there's going to be this eating away of the cliff. We have this process called undermining. Here we have vertical sorting. Vertical means up and down, and what we generally have are the larger sediments going to be at the bottom, and then they're going to get smaller and smaller till the smallest are at the top. So these sediments are going to be separated. Just a reminder that a young river is usually going to be more straight, and it's going to be very fast, while a maturing river is going to be less steep, more meandering, more curved. Remember that word meandering means curved, and it's going to slow down a bit, while an old river is going to be more meandering and very slow. Now remember, deposition means dropping off, depositing, and then what I need you to know is that on the outside of the curve, it's going to eat away or erode the surface of the land. But on the inside of the curve, that's where a lot of the deposition will happen, on the inside of the curve. Now let's revisit the water cycle as we talked about all those terms. The water cycle is also known as the hydrologic cycle. That's something that you do need to know. The water cycle really has no start and stop point, no number 1, 2, and 3, but you can start anywhere. It is a cycle in which it does move consistently. Okay, so there is no beginning or end. So here you can see evaporation, usually in the direction of moving up, while precipitation is going down. Transpiration, water coming out of leaves. So technically, if it's going up, that would be evapotranspiration.